Hi, I'm Iain and welcome back to the Northland Workshop. If you rip long boards on your table saw, then you really need something on the back of it to catch the workpieces as they come off the saw. If you don't, they could fall on the floor or they could get too tippy and that might not be safe. Now for about 12 years, what I've been using as an outfeed table for my table saw has been a fold-up ironing board with a piece of MDF on top. And that's worked perfectly fine. But I decided the time has come to upgrade. This is the little outfeed table that I made. And it's more of an outfeed cart than anything else. It's got a storage compartment underneath that I'm storing some biscuits, a dado head, molding head, and some dowels in. Then it has a piece of pegboard with hooks that you can hang tools on. You'll notice that the pegboard is situated towards the front of the cart, and that is because the motor of the table saw on this model hangs out the back. So by moving the pegboard forward, that gives me an open space in the back for the motor to hang. Now we need to take a second and talk about where the idea for this little outfeed cart came from. And the idea was actually a set of plans that was originally published in the Workbench magazine in June of 2006. So if you want the plans for this thing, the original plans, I mean not the modified ones, the original plans are from Workbench magazine, June 2006. And as you can see from this picture, it looks very similar to what we have here. I did go ahead and change a few things on it, such as the material for the top. The original plans just used a piece of plywood. I went ahead with the melamine and the maple edging for durability. They used a pine face frame for the front and the back. I went ahead and used iron-on edge banding for the front and the back, and I resized all the pieces accordingly. Also, I had to change the height of this thing because my table saw is on a mobile base, and even though my table saw is the same model that is shown in the plans, the mobile base lifted it about 1.25 inches off the ground. So I had to modify that to suit. So I came up with these drawings, and with these rough sketches in hand, let's get started building this little outfeed cart. For me, the first step for any project that involves plywood is to start cross-cutting it at the workbench using my circular saw and a straight edge. Now this circular saw has the benefit of being able to be hooked to a tool-operated shop vac, so that helps keep the dust down quite a bit. Now with the help of my table saw, I can go ahead and start ripping the pieces of plywood down to width. One thing I want to keep in mind is because the teeth of the table saw cut down, I want to have the good face facing up to reduce the chip out that I see on the good face. The other thing that helps reduce chip out is to use a zero clearance insert. The process to size the panels is pretty easy, and it starts with first running one edge through the table saw using my panel cutting jig in order to make sure it's perfectly 90 degrees. I never trust the cuts that I make with the circular saw to be 90 degrees, but I know this thing is 90 degrees. With this edge trimmed to 90 degrees, I can go ahead and spin the panel around, keeping the good face up so any chip out happens on the bottom, and I can measure 26 inches, and then I'll be able to trim this to length. Now I'll repeat that process for all the rest of the panels. You'll notice I've installed the dado head in the table saw, and I've also installed the sacrificial fence so that way I don't damage the metal rip fence with the very edge of the dado head. The reason I have the dado head in here is I need to make a rabbet in the bottom of each side of the cabinet to accept the bottom of the little cart. By moving the rip fence over 10.5 inches, I'm able to cut the dado for the top shelf in the side pieces. I'm using a 1/4 inch straight cutting bit to route a groove that will receive the 1/4 inch pegboard so I can hang tools on the front of this little outfeed cart. The top shelf gets the exact same dado to hold the pegboard. The back is getting joined to the sides and the shelf of the case with these number 20 biscuits. These biscuits are little baseball shaped pieces of compressed beechwood that when you add glue to them swell up, and it makes a really tight joint, and it'll reinforce this edge joint very nicely. The key to cutting a biscuit slot is a biscuit joiner, and this is one style of biscuit joiner that has a little sight window in it that you can line up with your layout line, and then there's a blade that pivots out that cuts the slot for the biscuit itself. All I need to do is line it up where I made the mark, and there's a corresponding mark on the shelf in the cabinet, and I can make the slot. And just like that, I have a slot for a biscuit. The top is going to get attached to the sides using pocket hole screws, and I'm going to cut those pocket hole screw holes over here at my pocket hole screw station. Time to start the assembly, and I'm going to start out gluing the biscuits into this side piece. And I've got this little glue bottle that has a special tip for spreading glue in the biscuit slots, and I found that to be the best way to do it without making a great big mess. sheet of glue down this dado. This is where the fun begins. I put the shelf in there, making sure that those dados are lined up, and they are. Now I can go ahead and put this back in place. This top stretcher gets installed with glue and pocket hole screws. Big thing here is to make sure it's lined up with the back edge of the dado for the pegboard. I don't want to see the edges of the plywood, so I went ahead and when I bought the plywood, I bought edge banding for it. In this case, this is some birch edge banding because this is birch plywood. It has hot melt glue spread on the back, and this just comes on a big roll. All I have to do to apply it is, I like to pre-cut it so it's a little bit longer than it needs to be. Start at one end and take my trusty iron and just start ironing it on. First thing I want to do is kind of tack it down on one end. Just to make sure it doesn't go anywhere. Once that's in place, I can go ahead and work my way down to the other end. What I like to do is iron it a little bit, do about a foot at a time, and then take an old chunk of 2x4, because it's got rounded edges to it, and just really press down on the edge banding to get rid of any little air pockets or voids that might be in it. I'm also tipping the 2x4 side to side ever so slightly to make sure I get a good connection between the edge banding and the plywood. I don't want voids on the sides. Once that cools down a little bit and it solidifies, I can go ahead and do the next foot. With the edges done, it's time to do this intermediate shelf, and I've pre-cut that as well, and you'll see it actually overhangs the sides by a bit, and that's done deliberately, so that way if it shifts a little bit as I start to install it, that's okay, because I'll trim off the excess one way or another. I want to start in the middle this time and start heating it up and sticking it down. Again, taking the 2x4, pushing the air out. Once that's firmly held in place, I can start working my way towards one side. you're going to notice that I left this little part unglued. What I've got to do now is trim it so I get a nice intersection between this edge and the other edge. I don't want to have a gap right there. So I'm going to take my little combination square and line it up so that way the blade of the square is right up against this side piece. And I'm going to take my utility knife and just score the edge banding until it cuts through. There. Now I can go ahead and iron this piece on. And just like that, I get a nice tight joint, and I'll repeat that process on the other end. They make a special tool for trimming the edge banding flush, and if I did a lot of edge banding, that would be a good choice. However, for the little bit I do, I find this little block plane works just as well, and it was something I already own. On the inside, I can use the block plane and get pretty close to the corners, but not completely in the corners. For that, I'm going to use a 1-inch wide chisel resting flat on the panel and real gently clean up the corners. Then I can go over everything with some 120 grit sandpaper and make sure everything's perfectly smooth. I'm over here at the real arm saw, and I've got it set up in the rip mode. And the reason for that is I need to rip this piece of pegboard to 26 inches wide. That's 2 inches wider than I can rip on my table saw. So, radial arm saw it is. There's one thing I need to keep in mind whenever I'm ripping on a radial arm saw, and that is that unlike cross-cutting, ripping requires that I feed the wood opposing the rotation of the blade. So right now, the blade is trying to rotate this way, I need to feed the pegboard in this way. If I feed the wood in the wrong way, so the blade's rotating this way and I feed it in this way, there's a really good chance it's just going to grab the wood and throw it out the other side, damaging something in my workshop, or possibly damaging me if it drags my hands into the blade with it. So I always have to make sure that I rip in the correct direction on the radial arm saw. So it's an extra thing to think about. This final rip is well within the range that my table saw could make, but I've got the radial arm saw set up for ripping at this point, and let's face it, it's my favorite power tool, so I like to use it whenever possible. With glue in the slots, I can go ahead and install the pegboard. I want to glue the pegboard in so that way the weight of the tools don't cause it to bow out over time. Now what I want to do is just bend it up a little bit, put a little bead of glue right in the center to help hold it in place. Along with the glue, I'm using some drywall screws to attach the top of the pegboard to that 2-inch stretcher that we installed earlier, just because all the weight of the tools is going to try and bend this piece out. I'm pre-drilling the holes because I don't want these screws to split that plywood stretcher. With the good side of the top facing down on the workbench and the bad side facing up, I've flipped the whole cart upside down, and I'm now attaching the top to the side of the cart using the pocket hole screws that we drilled earlier. No glue, because glue really doesn't stick to melamine. I've got the outfeed cart sitting on an old piece of plywood on the floor just so I don't scratch up the top, and I'm in the process of gluing and screwing these little 3/4 inch plywood squares to the bottom. What these will do is give the lag screws for the casters a bit more material to bite into than just one layer of plywood. All I do is line it up in the corner. I'll go ahead and put one screw in the middle. And then 2 on this side because the caster will be over here, so these won't be in the way. A 7/16 socket and a very long extension are the easiest way I've found to drive these lag screws in. I don't want to tighten them down until I get them all in, just in case I have to shift it slightly to line up one of the holes. I've swung the rail arm saw to 45 degrees and installed this sacrificial fence. What that's going to allow me to do is miter the maple edge banding that I'm going to use on the top of the outfeed cart. The nice thing about having the sacrificial fence here is I can line up the cut line with the kerf cut in it by the blade and know I'm going to get the cut right there every single time. To attach the maple strips to the tabletop, I'm again turning to the biscuit joiner. This time I've marked lines on the maple and on the melamine, and I can go ahead and cut the corresponding slots. When it comes to the slots on the maple edging itself, I want to actually make those slots a little deeper than normal because that also makes them wider than normal, and that'll give me a little bit extra wiggle room to slide this piece back and forth to get the miters to line up perfectly. With glue in the biscuit slots and on the maple trim, I can go ahead and install this piece of edge banding. I want to take the next piece, make sure I line up the corner correctly. Chamfering the edge like this is going to allow the boards to slide on and off this outfeed table much easier because they won't be getting caught on the corner. Plus, it'll reduce the likelihood that this maple chips. And, as an added bonus, this maple is pretty sharp and I could get cut on it. I won't be getting cut on this big chamfer. The very last thing I need to do to this little outfeed table is to route 2 grooves in it to accept the miter bar from the miter gauge. That way, as I push the miter gauge or the panel cutting sled through, it won't hit the edge of this table and cause it to bind up. I've gone ahead and installed this straight edge the correct distance away from where the miter slot needs to be, and I've installed this piece of plywood to act as a stop for the router, so that way I get the correct length to this slot. Now what I'm going to use is my router with a 3/4 inch mortising bit, and I'm just going to take my time going along making this cut. Now I can reposition the fence and do it again, completing the final width of the cut.